Hello everyone. Today we will discuss on chapter 5, which is synchronous sequence of logic. A sequential circuit consists of combination of circuit which is to store the element and to conduct from the feedback path. That means we are getting input here in the conditional circuit, and in this memory element we are getting the output, and then it will give the output to this combinational circuit for feedback section. If it generates a feedback, then and the feedback is getting as an input, so this is known as a serial circuit. The synchronous serial circuit means we are having a block diagram here of synchronous sequential circuit. Here we have combinational circuit first, then it will generate the output, and another output is going to the flip-flop section with the clock pulse, and the feedback is again going to the combination of circuit as an input. This is how the synchronous sequential circuit works. This diagram is very important for your examination. Asynchronous circuit is the division of bits. That means in synchronous section you have the continuous section, but in asynchronous section it sometimes breaken into sections. That is why it is known as the asynchronous synchronous circuit. Here we have some description of latch, and in this latch section we have the SR latch. The major difference among the various types of storage element are the number of input possible and manner of input affected by the states. Latch are said to be the label sensitive devices, like as flip-flops are age sensitive devices. In this section we can see that here we have an NOR gate, and this is also another NOR gate. We are having reset here and set on the bottom. This is the logical diagram, and this is the functional table. Here we are having the values as like as S and R. 1 0, this is from 0 0 to 1 1, which is from 0 to 3, and 1 0 is the opposite function. Here in this diagram we can see that if the value is 0, then it can generate the reset pulse, and the output of the reset pulse is getting the input of the S latch, and the result of S latch is going to the output of the R latch. That's the reason how they generated the Q and Q naught. For 0 0, here the generation of Q is 1 and Q naught is 0, and so on. Lastly, when we have the input as 1 1, then we get the output as 0 0 because they are having NOT gate in front of them. That is why 1 is turned into 0 and 0 is turned into 1. That is why 1 into 0 and this one into again 0. The previous one was the RS latch, and this section we are having the SR latch. In this section we have just opposited the function. That is why we are giving here 1 to 0 and 1 to 0. Here we are having the diagram of functional table, which looks like this one for SR latch. The difference between latch and flip-flop is very important for your examination point of view. Have a snap of this one. Now we are in the chapter 6, which is resistors and counters. Resistors are used to store data as like as the flip-flops, and counter is to count data like as in clock you count seconds 0 1 2 3 4 5, like this works like as counter. In this resistor section we have the several resistors are working here. Here we have the input as clock and input which is R. Here we are having data from D and output as A0 to A3, which are known as resistors. Here we have the shift resistor. Shift resistors means nothing but here we have the clock value and output are in the serial input. This output of first resistor is the input of second one, then the third one, and then the fourth one. Those are working as shifting this to this, this to this, and this to this. That's why they are known as shift registers. Resistor with parallel loading. In this section, resistors are working in parallel section. That is why they're doing their job in this parallel section. This diagram of parallel is also very important for examination. Here we have one clock section which is connected individually to each of those resistors, and here the input is coming from the load section and another input is coming from the direct line. Here are some points about universal shift resistor. You can have a snap of them and go through. Now, the ripple counter. The ripple counter is consists of serial connection of complementing flip-flops. Here we have counters from this to this. Here we are having the input from this, and each of the output is connected as the input of its next one. That is why it is known as a ripple counter, because when it generates the value 0, then another one generates the value 1, then 2, then 3. That is why the counter works, and this is known as the binary ripple counter. The diagram is very important. Have a snap of them. Those are with T pin flip-flops and those are with D pin flip-flops. Here we have discussed on BCD, which is known as binary coded decimal. You can have a snap of them and go through. In this section we have a ring counter which works on the shift register. That means the bits are shifting from here to there. That is why the value is increasing. If you have the first value which is 0, 0, 0 and 1, if you shift the 1 to the next position, then the value will become 0, 0, 1 and 0, which is 2. If you shift it again, the value will be changed to the 4. Then it will count as 0, 1, 0, 0, which is 4. That is how the ring counter works. That's for today. Have a snap of this counter. Thank you.